going to use a real world example to explain something that a subatomic particle, an electron, will do. This isn't the perfect illustration because it's just really hard to make real world spinning rides act like an electron. But this is a start, at least, to get an idea for it. Up until this point, we've been talking about an electron, and we've been talking about it goes in this path around the nucleus. I'm going to assume that's the nucleus because everyone knows that's the middle. And it's like a little planetary path that it goes around and around. But we've started doing calculations, and instead of there being like a little path, it's more like, do you see how there's like this region? So we all know that this picture in real life, it has those little swings on it, and you got like a person on it. And we need to assume there's just two people on it, because then that'll make it nice and balanced, and that makes it more like the electron. Because the electron, there's only going to be two people in it. Two electrons. All right, so here they go. And as soon as this ride starts spinning so fast that it blurs the way that this blurs, what we could say is we're like, oh, well, the person, they could be there, or they could be, over here, or they could be here, or they could be here. So what we're saying is that there's an area that the swings are in, and we know they're in that area because you can see the evidence like in the colors. We know there's not a swing over here, right? Because you can't see it in that region. So we can say, okay, the electron in the atom, it's not here, but we have evidence that it's in this kind of area. Of course, make sure you're thinking three-dimensionally. It's a three-dimensional area around the atom. So this is kind of a way to kind of start thinking about the electron. And remember that the electrons aren't just bound like this thing. Like we know this is like, it's got to go in one direction. The electrons aren't like that. The electrons, they kind of get to do their own thing. And I'm going to draw the electron as a particle. Remember, it has wave properties, so just keep that in mind. They kind of just like blip all over the place. We're not trying to say that these electrons are in and out of existence. They're still there. And again, there's only two. I know it looks like I'm drawing a lot of dots, but there's only two, but they're like in all of these little places at little moments in time. And you can also think of this like a camera that has its lens open for a really long time, the aperture. And like imagine a dog's running through the room, you'll get something that looks like a really, really long, crazy looking dog in your picture. So kind of like imagine that, like if you blur an electron's movement really, really fast, you've got a region that they're in, you have a region that they're not in, you also know they're not right there, right on top of the nucleus, but they got an area that they're in. So that's kind of how to think of what electrons do. They're in orbitals, spaces, but they're not in orbits like a planet.